related to linear programming problem. Means what? In linear programming problem, you see, suppose some equations are given, then we solve it by graphical method. So in graphical method means what? Uh, First, some definition. Sometime ask question. What is infeasible solution? What is basic solution? What is unbounded solution? Okay. So first you see infeasible solution. Have you got the note PDF file? Okay. Just so here you see. Here you see uh, the set of values of all of you see this one. First one is infeasible solution. So in infeasible solution, what is given? The set of values of decision variables xj. So you can write xi also, no problem. J varies from 1 to n, which do not satisfies all the constraints, and non-negativity condition of an linear programming problem simultaneously is said to constitute infeasible solution to that linear programming problem. What is the meaning? Okay, so last class we solve what? We solve the problem by graphically. How to solve the problem by graphical method? So here you see in graphical method, what? Suppose two variables are present, then we solve it by graphically. So after this we get the value of x1 and x2. What is the value of x1, what is the value of x2, like this. So in graphically there are two variable, means then j equal to 1 to 2, 1 and 2 we consider. So then after getting the solution, then you will see the value of x1 and x2 means decision variable. Decision variable values satisfies all the constraint. Decision variables means value satisfies all the constraint, and this is also non-negativity condition. Okay, so if this does not satisfy this condition, then this is called the infeasible region. Means in infeasible region, then you will not get what? Common region you will not get. Clear this one? Means what? Suppose one equation is say x1 plus x2 less than or equal to 2. So when we solve it by graphically, then after solving this we get the value, and if we get the feasible region, then we get the feasible solution, and if we do not get the feasible solution, then this is called the infeasible solution. Okay. Next one is what? Basic solution. So basic solution is what? You see, basic solution, you see the definition was basic solution. Have you got? Okay. So in, yes. So basic solution means what? For a set of m simultaneous equation in n variable, means m number equation and n variables. Okay, and if m equation and n variables, and if n is greater than m, means number of variable is greater than the number of equation. Suppose you write one equation, just you write one equation, all of you write x1 plus x2 plus x3 equal to 1. Then twice x1 plus 3x2 minus x3 equal to 3. Can we solve this problem?
Sir, can you please
Can we
repeat the first equation? I couldn't hear that.
x1 plus x2 plus x3 equal to 1,
Okay, sir.
and the second equation is 2x1 plus 3x2 minus x3 equal to 3. Clear equation?
Yes, sir.
Can we solve this problem, Abhishek?
অলপ চাব লাগিব।
ইকুৱেশ্যনটো লিখিছানে? লিখা নাই যদি লিখি লোৱা, মই আকৌ ৰিপিট কৰি দিম। লিখি লোৱা x1 plus x2 plus x3, x1 plus x2 plus x3 equal to 1, 2x1 plus 3x2 minus x3 equal to 3.
So we
Can
can
we solve this? Yes, Ishita.
solve this by elimination method.
Elimination method. So how to solve?
Sir, I don't think we can solve this by elimination method. We will require at least three equations
Yes. Uh,
for
Yes,
three variables.
yes, like
yes.
since three
Here
variables,
you see.
we'll need like three equations.
Yes. Here, how many equation?
Two,
Two equation. And how many variable?
three.
Three variable. So here you see number of equation means what? Number of equation is less than the number of variable, means number of variable is greater than number of equation. So you see this one, basic solution. For basic solution, first line is given. For a set of m simultaneous equation in n variables, n greater than m. Have you got this one, Roshni?
Yes, sir.
This line. Okay. So here you see which one is greater? Number of, which one is
Variable.
greater? Now,
Number of
yes,
variables
number
has
of
to be greater.
variable is, yes, number of variable is greater than the number of equation. So generally you see we cannot solve it if number of variable is greater than the number of equation, then we cannot solve this. Okay, but we solve this. How to solve? Then you see the language. Then comma, a solution obtained by setting n minus m variables equal to 0 and solving for remaining m equation in m equations in this one will be n variable. Yes, m variable is called basic solution. Means what is the meaning? Means then what we do, then from number of variable is suppose in the given example is number of variable is 3 and number of equation is 2. So we subtract number of variable minus number of equation. So our 3 minus 2 equal to 1. 3 minus 2 equal to 1. So we consider one variable is equal to 0. Variable is equal to 0, then we get what? Means two equation, two variable. Then this is called the basic solution.
Sir, like, what do you
This
mean by
is clear?
one variable equals to zero? Like, I mean, like, which
Uh,
variable equals to zero?
you can wish anyone.
Okay, sir.
Here x1, either x1 or x2 or x3. Anyone as your wish. Okay,
Okay, sir.
you can consider x3 equal to 0, or you can consider x2 equal to 0, or you can consider x1 equal to 0. Clear this one?
Yes, sir.
Yes, sir.
Uh, then if you consider suppose x3 equal to 0, the values of what? We get the values of whose values? If
X1
x
and X2.
x1 and x2, then this variable is called the basic variable, and this solution gives us the basic solution. So you see, everyone clear or not?
Yes, sir.
Clear? Okay.
Yes, sir.
Omlan, Arbaj,
Yes, sir.
Omlan.
Sir, I mean,
And one thing you say, after when you get, yes, Arbaj, yes.
yes, sir. Sir, I wanted to ask if the like basic solution is the like I mean the right solution. Usually like we don't use basic solution, right? But like I mean, is like basic solution the
Yes.
correct solution? Like whenever we want to use
Uh,
it, like
yes. Yes, so here you see in a basic solution, so depends upon the what as your consideration. Okay, means what? If you consider x3 equal to 0, then x3 is non-basic. Okay,
okay,
x3 is called the non-basic, and this x1 and x2, this is called the basic solution. Clear?
yes, sir.
So in next paragraph you see here, actually what happened, x3 equal to 0, then x3 variable will not appear in what? Appear in the next equation. So here next line we have written this one. The n minus m variable whose value did not appear in the solution are called non-basic variables, and the remaining m variables are called basic variables. Means did not appear in the in this solution are called the non-basic variable, and the remaining m variable are called the basic variable. Clear? So if you consider x3 equal to 0, then x3 is called the non-basic variable, and x1 is called the x1 and x2 called the basic variable. And next heading is unbounded solution. Okay, so unbounded solution is what? Just from its name, what do you say?
So,
Unbounded solution means
sir,
generally,
so it's not bounded by any like range, I guess. I mean, there's no like limit
yes,
or something.
means yes, 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 Roshni. So this one is what? There is no boundary. Roughly we can say there is no boundary. There is no range. Then this is called the unbounded. So unbounded means what? Solution means a solution which can increase or decrease the value of the objective function of the linear programming problem indefinitely is called an unbounded solution. Means what? When you will get the solution, when you will get the solution, means one graphically when we solve the linear programming problem, after this we get the values, we get the points. corner points, suppose A, B, C. Then point A, you will see there is some value substitute in the objective function. For point B, we get the another value when you substitute in the objective function Z. And then you will see if problem is maximization. Suppose problem is maximization. So at point A, you will get 20. Point B, you will get 30. Point C, then you will see means Z value is increasing like this, and your region is in unbounded side. Then we say that this gives us an unbounded solution. So related this problem, next question is related this definition, means you will get unbounded solution. First, what is our aim in graphical method? Whether this feasible region exists or not, means can we get the common region or not. So if we get the common region, then we get the solution lies in this common region. So this line is clear or not? Feasible region, then feasible solution.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so you see feasible region, for this region I have shaded, or you will get here shaded portion. So in shaded portion means what? This is our feasible region. So any point, you consider any point here. So this is the solution of this region, any point. So with the with this definition, we solve this problem, means how you will get the unbounded solution. So first use graphical. You got the question, everyone?
Yes, sir.
Okay.
So
So
3x1 plus 2x2.
yes,
This one.
3x1 plus 2x2. And subject to the constraint
X minus x2 less than or equal to 1.
1. Yes. And
x1 plus
x1.
x
Yes.
equal to 3.
3. Okay. So first you check, can we solve it by graphically? Here given use graphical method, but not mentioned. Suppose not mentioned. Solve the following linear programming problem. So first you check, can we solve it by graphically? Anyone? Can we solve it by graphical method?
Yes, sir.
Yes, sir.
Tirth Agarwal, can we solve it by graphical method? ये ग्राफिकल मेथड से सॉल्व होगा. If anybody you have any confusion, then you can ask or no. Omlan hobone, graphically can we solve? Omlan asa na nai?
I think yes,
So
sir.
why we can solve? When we cannot
So
solve?
because,
Yes.
so because the number of variable is 2. If it is more than 2, then we
Yes.
use another method.
So here you see, here how many variable? 2 variable. You will not see the number of constant, only you see the variable. Variable means what? X1, x2. So here how many variable? Here number of variable is 2, x1 and x2. Up to 2 variable we can solve graphically. So we can solve it by graphical method. So if we solve it by graphical method, okay, we use the procedure graphical method. So next you see its objective function is what? Its objective function is maximization. Okay, so you'll remember its objective function is maximization. And next you see the constraint. So here constraint is x1 minus x2 less than or equal to 1. And another constant is x1 plus x2 greater than or equal to 3. So So x1 minus x2 less than or equal to 1. So first you make it into equality. Means x1 minus x2 equal to 1. Okay. Then from here you find out the coordinates. You will get the 2 points. First you consider x2 0, x1 equal to 1. Means 1 and 0 is one coordinate. Next you put x1 0, then x2 equal to minus 1. Means you will get 0 and minus 1. Okay. Similarly, here 2 points. Similarly, you first make it equality x1 plus x2 equal to 3. So someone asked question, why sir we make it equality? Why we make it equality? Because this is the linear equation. Inequation. First is linear inequation. Its highest power of the variable is 1. So this is linear. And this linear always gives us a straight line. So when we get a straight line, if y equal to mx plus c format, so here greater than or equal to symbol and procedure for this region, we make it equality. Otherwise, we cannot get the straight line, because you see, for drawing one straight line we need what, how many points, 2 points. So if we make it equality, one variable 0, then we get the another variable to 0, then we get another variable value, so then we get the 2 points. Okay. Next, what is our aim? Our aim to draw the points. Next, you see the diagram. Coordinate O and x1 axis and x2 axis. You see the diagram? Diagram is okay or not? You see.
Yes, sir.
0 3 and 3 0. Just you put the mark. O means 0 means O means 0 0, and from here in x axis you mark unit length 1 2 3 4 5 6 like this. In x2 axis also you mark 1 2 3 4 5 6. Then you plot the value. Plot the value means what? One coordinate, I have not given here coordinate marking. I have not marking. You can mark. One coordinate is what? 0, 3. So 0, 3 lies in which axis? X2 axis. And 3, 0 in x1 axis. Then you draw the line. Clear? And next one will be 1, 0. So 1, 0 is 1, 0 in which axis? 1, 0 lies which axis? কোনটো axis থাকিব? Yes, x1 axis. Good. X1 axis. So x1 axis and 0, minus 1 কোনটো সাইডত যাব? 0, minus 1
Y axis.
x2, yes, y axis means x2 axis, and this lies where? Positive side or negative side?
Positive side.
Negative.
Minus 1, 0 lies in the negative side, but we will not consider. Only we consider the first quadrant. So for this region, you see here how many quadrant? 4 quadrant. First, second, third, fourth. So in fourth quadrant, you see I have not given any line. You can write dot line, but you will not write the continuous line. So continuous line will be formed in the first quadrant. Okay. Next question is, which region we consider for x1 minus x2 less than or equal to 0? Which region we consider? কোনটো সাইড আমি কনসিডার করি? x1 minus x2. x1 minus x2 less than or equal to 1, we get one equation, means we get one straight line. From this straight line, we consider which side? Upper one or lower one? How to check? You put x1 0, x2 0. So 0 less than or equal to 1 satisfies the inequality condition. So you see, if you added this dot dot line also, you see origin containing side means from line to above. And next one is x1 plus x2 greater than or equal to 0, 0, 0 greater than or equal to 3. So this inequation satisfies or not? Etu equation satisfy করিলে না নাই?
Not
No,
satisfied.
sir.
Not satisfied. So which region we consider
Uh,
from? Yes,
outside the origin.
means from line to above side. The line is you see 0, 3 and 3 comma 0 line is this. So we will not consider what outside this side, outside this region. So clear?
Yes, sir.
So outside
Sir, can
this
you
region.
repeat again?
Okay, so first one will be what you see. First one will be x1 minus x2. So when we substitute 0 less than 0, 0, 0 less than or equal to 1. So equation satisfies. So for this line, satisfies means origin
diagram to both
containing.
আছে sir.
Huh?
Diagram to
ডায়াগ্রাম তো তোমার সেকেন্ড পেজ টু সোয়া সেকেন্ড পেজৰ ফার্স্ট ডায়াগ্রাম তো সলিউশন টু লিখাৰ পিছত সোয়া এটা কোঅর্ডিনেট আছে b2,1 লিখা আছে বাকি কোঅর্ডিনেট লিখা নাই পাইছা নে তো সেই ডায়াগ্রাম তাতে তুমি আৰু এটা পয়েন্ট কেটা লিখি দিবা সি ডি এই যে 3,0 0,3 1,0 and then you will write the point, all the points you will write. ঠিক আছে পয়েন্ট কেটা লিখি দিবা তো এতিয়া তোমার ফার্স্ট ফর দা ফার্স্ট ইকুয়েশন for the first inequation line is 1,0 and 0,-1. So this satisfies the inequation to satisfy korile when we substitute 0, 0 means when we substitute 0, 0 means what origin bohar pisot amar equation to satisfies. So origin containing side and second line second inequation আছে x1 plus x2 greater than or equal to 3. So this is 3,0, 0,3. So line will be from outside. Means what? From line, the shaded region will not come in the origin side. This is away from the origin side. Means what? From line or pora outside of the what? Above the line. Okay. So then common region will be what? Common region just I have shaded this one. This one shaded portion you see. Clear? Arbaj, common region to
Yes, sir.
name of this region is called what? A common region of আমি কি কও?
Feasible.
Yes, feasible region. Okay, so feasible region is this one. Clear? Common region. So this is called the feasible region. So in this region, any point if you consider, then this satisfies the inequality. If you consider any point in this region, so you see there is any boundary in lower portion there is boundary, but in upper side there is any boundary?
No, sir.
Boundary আছে নেকি? No. You see this is unbounded. There is no boundary. So you again you move to the first page. I have written this language. You will write in language as in your language you can write. Not properly I have written here this one. Just you know the means what procedure, how to solve and how to write. In your language, you can write. So I have written here, the constraints are plotted on the graphs as usual as shown in the figure, a diagram. The solution space is shaded, feasible region means solution space means feasible region, shaded, and is bounded from the below. So in below side, this is bounded. And it is noted that shaded convex region means solution space is called the convex region, is unbounded from above. From the above, there is no boundary. The two corner points of the region are, you will mark the point. Okay, 0,3 you mark A. When you write in your copy 0,3, this point is 0,3 is A, and 2, B is 2,1. Then objective function at this concern is z of a coordinate. For a coordinate, what is the value of z? You substitute in the objective function 3x1 plus 2x2, means a is what? 3, 0. So 3, 0, 3. So when 0, 3, then this is 6. And when 2, 1, then this is 8. So which one is greater? In 6 and 8, which one is greater?
8.
8. So, but we consider here up to this 8 is our answer. But you see, since in the given linear programming problem is of maximization, there exists number of points in the shaded region for which the value of the objective function is more than 8. For example, in shaded region, you see, 2, you just consider the point 2, 3. 2, 3 lies where? Point 2, 3 lies in the shaded region,
Yes, sir.
means in the feasible region. Okay, so 2, 3 is also the solution. Again 2, 4.
Yes.
2, 4
Yes, sir.
also lies in the solution. So 2, 4, or you can consider 3, 4 in this way. So you see what happened. You see what happened here, the value of this point increases. Okay, 12, which is just we consider 2, 3, then this is the point 12, which is more than 8. Thus both variable and x1, x2 can be made arbitrarily large, and the value of z is also increases. Okay, and here the problem has an unbounded solution. Clear this one?
Yes, sir.
Yes, sir.
Okay. Okay. Arbaz, you take the attendance, okay?
Okay,
And
sir.
you will send me.
Okay, sir.
Okay?
Yes, sir.
Okay. So mm, you see this problem. This is the problem of unbounded solution. And next problem I have given. Next problem I have given. So you will see this one. So next class I shall discuss. Okay.
Okay, sir.
Okay, sir.
Okay. Thank you. Okay. So Arbaz, you take this one attendance and send.
Yes, I'm taking the
Thank you,
attendance.
sir.
Okay. Siddharth,
Yes, sir.
any question?